In number 15 here, we've got a limit as x approaches negative infinity of the natural log of x to the fourth plus 1 all over x. So the first thing, of course, we would try is plug and chug, and what's going to happen there? We end up now taking an infinite number, although it's negative, but that doesn't matter here. We're going to take it to the fourth power, which basically is approaching infinity. Plus 1 is irrelevant then. And the natural log of an infinite quantity, guys, if we think about the graph of natural log of x, the further out to the right you go, the higher you're going to go on the left. That approaches infinity on that top side right there. Now down on the bottom, the x approaches negative infinity. And the negative really isn't important here, guys. We end up with one of the indeterminate forms here, infinity over infinity, and negatives are okay. And that means that we can go ahead and use L'Hopital's rule. So what are we going to do here? That limit now is equal to, it's the limit as x approaches. Now, as I'm looking at the solutions manual here, guys, I noticed that once they started actually working on this problem, they left off the x approaches negative infinity and just start talking about x approaching positive infinity. So I'm wondering if that wasn't a typo in the original problem there that they had. So I'm going to just leave it as negative infinity. I really don't think that's going to change what we're doing that much. Let's see what we got. How do we take the derivative of our numerator? Natural log of a quantity. So the derivative of natural log of a quantity is 1 over whatever that quantity is, x to the fourth plus 1, and then multiplied by the derivative within. So I didn't put a 1 over the top because I knew we were going to multiply that by a 4x cubed to take the place of that 1. So that's the derivative of our numerator. The derivative of our denominator is just 1, which means I probably could have ignored that. Okay, and what happens then, guys, when we try to plug and chug at this point right here? Putting in a negative infinity, the numerator, 4 times negative infinity cubed, is going to end up being, that would be a negative infinity there. And then when we plug negative infinity here, negative infinity to the fourth power is positive infinity, plus 1 is positive infinity again. So we did L'Hopital's rule, but it didn't actually work out for us right here because we got another indeterminate form. So what do we do then? We keep trying this a second time now. We try to apply L'Hopital's rule one more time. Limit as x approaches negative infinity of, and now I'm just going to take the derivative of the top and bottom of this function right here. Derivative of 4x cubed is going to be a 12x squared. And the derivative of x to the fourth is going to be 4x cubed, and I don't have to worry about the 1 there. So I think we can kind of see what's happening here now, guys. These two x's are going to cancel with 2 of the x's right here, so that's just an x to the first, and then the 4 and the 12 cancel, leaving us with a 3 right there. So what happens at that point? Letting x actually become infinity, the numerator is just 3, and the denominator is just x, which is negative infinity right there. Or I should say x is approaching negative infinity for that one right there. And when your numerator stays the same and your bottom denominator increases without bound, that means that our limit then is equal to 0. So like I said, the fact that this was a limit as x approaches negative infinity and not positive infinity didn't really matter here at all. We ended up with a value of 0 either way.